Evening all. Question for the audience. How many of you are users of smartphones? Hands up. Okay, don't be shy. Okay. So you are, I guess, predominantly one of the drivers behind the need for this CSET. So let's consider about communications and how they have evolved over the past 10 years. So for example, both Vincent and Frank have made reference to the vast quantities of data that we as users are accessing. We access these through content or apps, through our devices, increasingly mobile devices. For mobile devices, we are communicating with the wireless infrastructure. We're using spectrum, and this is then going into the optical backbone of the core network, where we're using, let's say, the optical infrastructure. And increasingly, we're accessing data that's stored in data centers, or let's say, as we refer to the cloud. Here we are facing three specific constraints. Spectrum for wireless, fiber capacity for optical, and increasingly energy. The energy content, the energy requirement of the internet is doubling every 4 to 5 years. So these are some of the drivers behind our CSET. It's a highly distributed CSET. The various different partners are listed here. It's also multidisciplinary, so tackling issues in communications, we need electronic engineers, we need physicists, mechanical engineers, constraint programmers, photonic specialists, and a range of people who are network specialists as well. So these are found in the various different institutions. We engage heavily with industry in such an applied area. Companies ranging from the equipment supplier, Alcatel-Lucent, chip suppliers like Xilinx and NXP, Sokowave, CTVR spin-out, operators like Aircom, and also device companies like Intune Networks, and many more that we have contact with in this space. Obviously very important for such an applied engineering area. In terms of our research, unique for a telecommunications center, we have specialists both in the wireless or the radio side, and also the optical or the photonic side. And this gives us a unique advantage in tackling technological problems on both sides of the telecommunications challenge. So not only do the challenges in the wireless domain inform what the optical specialists are doing, but there's also translation, vice versa. In addition to that, we take a lot of energy from the interplay between the overall architecture of the network and how that evolves, and also the technologies, the underpinning technologies and how they evolve. So because we're represented in both domains, we can see how changes in architecture can drive device design, and how technological changes in devices will also influence the architecture. And on a final note, we believe that the networks of the future will be sustainable, which I think explains itself. We believe that they need to be evolvable, and we also believe that they will be submissive, which I'm not going to explain here. Thank you.